Okay. Hello, everybody. We're going to be doing some calculus. Let's start off with some piecewise functions. So let's jump straight into it. Example, as stated, it says find the values of A and B that F is continuous everywhere. And the function is f of x equals x squared minus 4 over x minus 2 for x is less than 2. Now we have ax squared minus bx plus 3 for 2 is less than or equal to x and x is less than 3. And finally we have 2x minus a plus b for x is greater than or equal to 3. So if I recall, what did I put Q? The domain of any rational function is all real numbers except for those that make the denominator 0. So as long as Q of x is not 0, then the domain is all real numbers. Let's just keep that in mind. So we can start off with evaluating this by the limit as x approaches 2 from the left. It's from the left because x is less than 2. So if we look at the number line, we have 2, and x is less than 2, so x is less than 2. So we're approaching 2 from the left. Okay? Of f of x equals the limit as x approaches 2 from the left of x squared minus 4 over x minus 2, which equals the limit as x approaches 2 from the left of x plus 2 times x minus 2 over x minus 2. And as she said, they cancel out, and we have the limit as x approaches 2 from the left of x plus 2 is equal to 2 plus 2 equals 4. Now remember that we stop writing the limit when we plug in the value. So whenever we start evaluating, we can stop writing the limit. We always want to make sure that you write the limit. And then we have the limit. What happened there? Sorry about that. So now we have the limit as x approaches 2 from the right of f of x equals the limit as x approaches 2 from the right of ax squared minus bx plus 3, which is equal to a2 times 2 squared minus b times 2 plus 3, which is 4a minus 2b plus 3. So, therefore, we have the limit as x approaches 2 of f of x equals 4, and it equals 4a minus 2b plus 3. Remember that it is asking us to evaluate or find, I mean, the values of A and B. So let's just keep that in mind. Now if we continue, we have the limit as x approaches 3 from the left of f of x equals the limit as x approaches 3 from the left of ax squared minus bx plus 3. And now we can start writing the limit because we're going to evaluate. 3 squared minus b times 3 plus 3. We have 3 squared is 9a minus 3b plus 3. And remember that x is also greater than 3. So we have the limit as x approaches 3 from the right of f of x equals the limit of x as the limit of f of x as x approaches 3 from the right. In this case, we're going to be using this because x is greater than. Okay? Just make sure to keep that in mind. So we have 2x minus a plus b equals 2 times 3 minus a plus b. And 2 times 3, 6 minus a plus b. And we can be decent and write it in order. Plus 6. So we have the limit as x approaches 3 of f of x equals 9a minus 3b plus 3 and negative a plus b plus 6. All right, let's write these in a different color just so we know. Okay, now from here we can do some interesting things. Normally if you have more than 2 or 3 variables, you can solve by doing a system of linear equations. 4 equals, what was it? 4a minus 2b plus 3 over 9a. Oh, sorry. 9a minus 3b plus 3 equals negative a plus b plus 6. You could also do matrices, but it'll probably take you longer to do that. So you can just solve. And we can do minus 3, minus 3. We can do minus 6, minus 6, plus 9. And plus 3. Oh, 9a and 3b. Just to make sure, you know. So we have 4 minus 3, it's 1. It's equal to 4a minus 2b. And here we have 10a minus 4b equals 3. Double checking that everything's okay. And so from here, what we can do now is multiply this by 2. Or negative 2. And then we would have, whoops. Now, oh my gosh. Then we would have negative 2 equals negative a plus 4b, which equals 3. 10a minus 4b. 4b minus 4b equals 0. Negative 8 plus 10 equals 2a. And negative 2 plus 3 is 1. So my a equals 1/2. And if we go back and plug in the a, we get whoops. Well, we should get 4 divided by 2 is 2. 1 minus 2 is negative 1 equals negative 2b. So b equals negative negative. Cancel out, over 2. 1/2 also equals b. Would you look at that? So, top it off, thus the limit of f of x as x approaches 2 equals 4 times 1/2 minus 2 times 1/2 plus 3 equals 4, which equals f of 2. Because if we have f of 2, just as a reminder, if we have f of 2 and we plug it into where it gives me equal, less than or equal to, we have a times 2 squared minus b times 2 plus 3. Which is equal to 4. Two minus 1 plus 3 equals 4. So, let's keep going. And the limit as x approaches 2, 3 of f of x equals negative 1/2 plus 1/2 plus 6 equals 6. Negative 1/2 plus 1/2 give you 0. So it just equals 6, which also equals f of 3. Because again, if we plug in f of 3 into this function, because x is greater than or equal to 3, then we would have two times 3 minus 1/2 plus 1/2. Negative 1/2 plus 1/2 is 0. 2 times 3 is 6. Therefore, when a equals 1/2, and b equals 1/2 f of x is continuous everywhere. Thanks for watching. Like and subscribe.